The machine looks ordinary right up to the moment it stops being ordinary. A work cycle is already underway, heat already moving, pressure already held inside steel, and the people near it are doing what they have done so many times before. That repetition itself feels like proof. Then the vessel fails. Not gradually in the way fear imagines, but all at once in the way stored force prefers to arrive when containment is finally lost. In a single break, the familiar center of useful power becomes a source of irreversible violence, and the real question begins there. How does something so common become something so predictably catastrophic? It becomes catastrophic because it first becomes indispensable. The system matters before anyone asks what its hidden price might be. It takes older limits on labor, distance, timing, and output and pushes past them by storing force in one place, then releasing it where work needs to happen. That promise is too powerful to ignore. Entire routines begin to gather around it. Production speeds up. Buildings are planned around it. Streets, schedules, and expectations begin to assume that concentrated power will always be available when demanded. Long before the rupture, dependence is already in place. And dependence has a way of making danger feel less like danger and more like infrastructure. That dependence deepens because one vessel rarely serves one task alone. One machine supports many lines of work at once. One room sustains multiple outputs. One source of stored heat and pressure reaches beyond its own walls into connected operations, connected timetables, connected people. Efficiency looks like consolidation. The very feature that makes the system economically attractive also turns it into a single point of failure. If the force is centralized, then the consequences are centralized too. The same arrangement that makes the day run smoothly under normal conditions ensures that when failure arrives, it does not stay local for long. It travels through everything that had quietly learned to rely on the calm inside that shell. And that shell is never placed far away from human bodies. It is brought close because closeness improves output. The energy is most useful when it does not have to travel far before becoming motion, heat, timing, and work. So the vessel is not an abstract hazard locked safely beyond reach. It is embedded near the workforce, near the floor that carries the load, near the walls that hold the routine together. Proximity is productive. Proximity is profitable. Proximity also means exposure. When concentrated force is housed beside the people whose labor depends on it, efficiency and vulnerability become the same design choice viewed from different sides. The system is not dangerous despite its placement. It is dangerous partly because of it. The construction reflects that same bargain. A pressure vessel is not simply a container. It is a promise that material, shape, joints, fasteners, fittings, anchors, and boundaries will keep force obedient for one more hour, one more shift, one more day. Its body is assembled to hold what cannot be seen directly once operation becomes routine. Its supports are meant to keep mass stable. Its connections are meant to regulate flow. Its openings, closures, and protective components all exist to make stored energy useful without letting that energy write its own terms. But every choice that makes the vessel strong also creates a new place where weakness can hide. A seam can age. A surface can thin. A fitting can drift. An anchor can hold until the instant holding is no longer enough. So routine operation becomes a discipline of constant balance. The operator does not command infinite power. The operator manages a system that remains useful only by staying within limits. It is always tempted to approach. Heat must be fed. Pressure must be watched. Water, metal, time, and use must remain in relationship. Maintenance is not an occasional interruption to normal work. Maintenance is part of normal work. Attention is part of the system. Vigilance is one of its operating components, even though vigilance cannot be bolted in place the way steel can. That is why the daily cycle is deceptive. When a dangerous system runs smoothly, what people often see is reliability. What they are really seeing is successful management of risk, repeated so often that the management itself becomes invisible. Inside that invisibility is physics that never stops pressing against the boundary. Stored pressure and heat do not look dramatic while containment holds. The vessel can appear almost motionless. Its exterior can seem calm, even dull, while the interior exists in a state that would become violent the moment restraint fails. This is the central illusion of concentrated force. The stillness of the outside teaches people to underestimate the intensity of the inside. The system works precisely because the boundary is doing more than the eye can measure in an ordinary glance. It is containing not just heat, not just pressure, but timing, consequence, and delay. The calm surface is not evidence that danger is absent. It is evidence that danger is currently imprisoned. And imprisonment never remains perfect. The operating cycle itself becomes part of the wear. Repetition has a cost. Heating and cooling, expansion and contraction, moisture where it should not remain, corrosion where inspection is imperfect, material limits approached, then approached again, small losses that don't look like a final break because they are not yet a final break. Damage accumulates before anyone can point to a single dramatic moment and call it the beginning. By the time the decisive weakness exists, it has often been made gradually by ordinary use. That is what makes the threat so difficult to feel at full scale. The system teaches everyone to fear the instant of rupture, when in truth, the disaster has been under construction for much longer than the final sound suggests. The warning pattern appears early, but not early enough to command the respect it deserves. A leak here, a sound there, a trip, a patch, a workaround, a minor interruption absorbed into the vocabulary of maintenance. The signs are real, but they are often interpreted at the smallest possible scale because small interpretations are easier to live with. If the leak is just a leak, work continues. If the noise is just noise, work continues. If the fix holds for now, then now becomes the only time horizon that matters. This is how warning signs become normalized. They do not vanish. They are domesticated. The system teaches people to translate evidence of growing instability into evidence that the routine is still manageable. And that translation is one of the most dangerous functions in the whole chain. From there, the possible triggers multiply, even if the underlying logic remains the same. One failure path may begin with thinning material. Another may emerge through pressure that exceeds what a weakened boundary can safely contain. Another may form around fatigue, neglected components, compromised relief, flawed assembly, imperfect inspection, or thermal stress carried for too long. The details vary, but the pattern does not. The system stores force in one place, relies on containment, ages under use, and rewards continuity of operation. Different routes lead to the same edge. That is why recurrence is so damning. Repetition across different circumstances reveals that the catastrophe is not merely the product of bad luck. It is the product of a design logic that can fail in more than one way while still appearing efficient almost right up to the end. When the final chain begins, it often starts at a scale too small to match what follows. A tiny breach is enough. A weakness becomes an opening. Containment is no longer total, so pressure stops behaving like a disciplined reserve and starts behaving like escape. The vessel loses the condition that made it useful. Stress redistributes instantly. Metal that held under one pattern of force is suddenly asked to survive another. What had been restrained now accelerates the failure of whatever remains. The breach widens. The wall gives. The body of the vessel can no longer negotiate with what it once contained. And then rupture completes itself with brutal speed, converting stored force into impact, fragmentation, violent displacement, and heat released into places never meant to receive it. The damage field expands far beyond the point of origin. Fragments become projectiles. Pressure becomes a moving blow. Heat joins debris, and structural elements that were never the first problem become part of the second one. The building suffers not only from what breaks at the center, but from what that break throws outward into floors, walls, openings, adjacent systems, and whatever stands nearby. The street becomes part of the event. Glass, dust, metal, smoke, and collapsing sections carry the violence beyond the room where the vessel stood. People who were not touching the machine still enter its reach. That is what concentrated energy does when released catastrophically. It rewrites the boundary between direct exposure and surrounding life until the whole area is forced to participate in the consequence. After the rupture comes a different kind of disorder, not the hidden order of pressure held in steel, but the visible disorder of people trying to understand what has happened quickly enough to survive it. Confusion leads, rescue strains against damage, obstruction, heat, noise, injury, missing information, and the instability that still lingers after the first blast. Work stops, but the stopping is not clean. The economic shock spreads through interrupted output, damaged property, halted routines, and lost confidence in what had seemed dependable. Families enter the cost long after the vessel has already broken. So do neighbors, workers not in the room, small businesses, public services, and everyone whose day had been tied to the ordinary promise that the system would keep functioning. The aftermath is never confined to the official point of failure. It radiates through the social body, the way pressure once radiated through the machine. Then the hardest question arrives. If the pattern is so legible, why does it continue? Part of the answer lies in incentives. The system is useful, and usefulness protects itself. Owners can remain insulated by scale, by distance, by replacing one damaged unit or one damaged workforce with another operation. Suppliers can survive by treating components as transactions rather than consequences. Gatekeepers can survive by allowing continuity to outrank deeper redesign. The exposed do not have that distance. Workers stand near the vessel. Families absorb the loss without sharing the benefits that once justified the risk. This is why repetition can coexist with recognition. A dangerous system does not need to be universally trusted to persist. It only needs enough participants with enough incentive to accept the concentration of risk as an ordinary cost paid mostly by other people. Attempts at reform often begin where systems are most comfortable changing: in partial safeguards, better components, improved inspection, stronger routines, more reliable protective features, clearer procedures. These changes matter. They can reduce frequency. They can interrupt some pathways to disaster. They can force warning signs to be taken more seriously than before. But even useful reforms can leave the core concentration intact. The same basic arrangement may still place enormous stored force inside a boundary that ages near the people and structures that depend on it, within an economic logic that rewards continuous output. Incremental fixes can make the system less reckless without making it fundamentally safe. The question is not whether safeguards help. The question is whether they change the architecture of exposure or merely manage it more competently. Eventually, another system appears, not necessarily because memory becomes pure, but because comparison becomes unforgiving. A replacement gains ground by offering power, timing, or distribution without demanding that so much force remain concentrated in one vessel at the heart of daily work. The pivot is practical before it is moral. Cheaper can matter. Easier to distribute can matter. Easier to separate from bodies and walls can matter. A new system does not erase what came before, but it alters what people are willing to tolerate from the old one. And that is the legacy hidden inside these earlier failures. Modern codes, layered safeguards, and the trust people place in ordinary infrastructure were not born from comfort. They were written by consequence. That is why the silent giants matter even after they are replaced, regulated, or forgotten into the background of history. Their lesson is not simply that pressure can explode. It is that dependence can hide risk, that routine can normalize warning, that efficiency can gather too much consequence into one place, and that the people nearest the system often pay first for decisions made far from the point of impact. What erased city blocks was never only force. It was force made ordinary, force made useful, force made profitable, force allowed to remain close until the line between service and catastrophe disappeared. The safeguards that came later are not monuments to progress alone. They are memorials to failure, and they remain trustworthy only as long as that failure is remembered.